Hi, in this video we'll do a few examples where we integrate inverse functions of inverse trigonometric functions. And again, if you refer to your book on page 385, there's a complete list of integration rules. Included on that list are the inverse trigonometric functions. Okay, and basically they're formulas, and you have to learn how to recognize the formulas. And so I have 3 examples here to go through. The first thing I notice about number 2 is they have a square root in the denominator, and that 1 is a perfect square and 4x squared is also a perfect square. So if I take my a to be 1 and my u to be 2x, okay, then this actually looks like the derivative over a squared minus u squared. The derivative of u is just going to be 2. And so I need to have the derivative of u, which would be 2. I'm missing that, so I can multiply a 2 here. But then remember, I have to also multiply by 1/2, so then I will change it. So now I'm ready to integrate. I'm going to have that 1/2, and now referring to my formulas on page 385, I see formula number 18 is the derivative over the square root of a squared minus u squared, and that equals arc sine of u, in this case my u is 2x, over a, which is 1, and then plus my constant. So I can rewrite this simply as 1/2 the arc sine 2x, and then plus my constant. All right. In number 6, I don't have the square root, so that formula is kind of off the table, but I do notice that I have a perfect square here, so that's going to be my a, and that'll be equal to 2 because 2 squared is 4. And I have a perfect square here. So again, this will be my u part. And I'm adding the 2, so that's x minus 3. And again, I need to make sure I have the derivative of my u, which would just be 1 in this case. Looking through my formulas on page 385, I see that this pretty much resembles the formula 19, where I have the derivative over a squared plus u squared. All right, and so this is just going to equal, according to that formula, 1 over a, which is 1/2, arctangent u, in this case my u is x minus 3, divided by a, again, which is 2 in this case, and then plus my constant. All right, so the key to these is not that they're very hard to integrate, it's just finding the correct formula to match them up to. Again, down here in number 15, I see that I have a square root again, okay, and I have a perfect square and a perfect square. In this case, my a is going to be 5, all right, because 5 squared is 25, and my u is just going to be the tangent x, okay, and I have a u squared right here. This is starting to resemble formula number 18 from page 385, but I need to make sure that I have du. Recall that the derivative of the tangent of x is just equal to the secant squared x. All right, and that's good for me because notice here that I now have my du right here, secant squared x dx. So then this is going to match up with the formula 19, or I'm sorry, with formula 18, which is the derivative of u, okay, over the square root of a squared minus u squared, and that's equal to the arc sine of u, which is my tangent x, divided by my a, which is 5, plus my constant. I hope these examples help. If you need more, please just let me know.